Okay, folks, we are going to start talking about angled velocity. So when up to now, if you remember, I have been really hitting home that positive and negative don't indicate gain or loss. It was an easy mathematical way to say that something was going in the positive direction or in the negative direction without having to draw a vector, without having to talk about vectors. Okay, but now, if you are going up this escalator, you are doing two things at once because you are just that fancy. You are going to the left and up at the same time, right? So as you go up the escalator, Woodley Park Metro, you're going both horizontally and vertically. And what's a little bit confusing is your upward motion is positive, but your leftward motion is negative. So, excuse me, that's why we have to be really, really careful. Up to now, something either had a positive or negative direction. As soon as the vector is what I call crooked, it's really carrying two pieces of information. It's carrying the over information, which could be positive or negative, and the up or down information, which could be positive or negative. All right, so that's why you're going to see a diagram, and that's why it's not easy to say. That's why we're going to call the actual vector the speed, and that's always going to be what's called the magnitude of the vector. So like if there's an earthquake, they'll say what's the magnitude of the earthquake, which means like how big is it? Or they'll say what's the magnitude of whatever problem you think Congress is talking about this week. So the magnitude of the vector is how long it is, and that visually can represent how fast you're going. So, you know, this vector, this blue vector is longer than this blue vector. These two objects are traveling in the same direction, but the first one I drew was going faster. So the magnitude of the velocity vector is called the speed. That's just what the speedometer excuse me, would record. And then we're going to look at what else there is to learn about it in terms of how far over and how far up you're going. Okay, so crooked vectors are doing two things at once. I think we talked about that enough. I don't think we need to see that. All right, so please write this down in your notes. So the vector itself, the speed, actually, sorry, the vector itself has a direction. So that, I'm so sorry. That we call the velocity. The velocity is the speed plus direction. So the velocity is always, always, always the hypotenuse. Okay? Most of the time, that's what you know. So this hypotenuse is the length of it is your speed. The actual vector, hope this isn't confusing, the actual vector we call the velocity because the actual vector is tilted. It has both speed, which is the length, and direction, which is the angle. Okay, but the length of that side of the triangle is the speed. And this is how quickly you're traveling upward at that instant. So we're going to call that Vy. This length is how quickly you're traveling over at that instant. We're going to call that Vx. Okay, so when you throw a ball in the air, the instant you release it, you've given it a little bit of upward velocity and a little bit of over velocity. And you want to know which is which, right? Because the upward velocity is going to determine how much time it spends in the air, and the over velocity is going to determine how fast it's covering ground. So we're going to figure out how to calculate the Vy and the Vx. So I'm going to call the speed V. So if there is no subscript, it's just understood that's the speed. that's what the speedometer would record. If there's a subscript, you're indicating it's either my horizontal or my vertical velocity. Okay, so we're just going to set up so the sine of theta, which you'll know, we're going to do a problem at the end of this, equals the opposite, which is your Vy, over the hypotenuse, which is your total speed. All right, and then we want to know, hey, what's my Vy? How high is this thing going to go? So we're going to multiply both sides by V, and you get my upward part of the velocity is my total velocity times the sine of theta. And if you remember, the sine of theta can never be bigger than 1 or negative 1. So I'm going to take my total speed, and I'm going to multiply it by something that is less than 1, which makes sense, right? That my upward speed cannot be bigger than the total. So that is the formula for how quickly the object is moving upward at that instant. So please write that down. And I apologize for the coughing one more time. All right, now we're going to set up the same thing for the, so we did so, now we're going to do ca. So the cosine of whatever this angle is adjacent, which is how fast I'm headed over my total speed. And I want to solve for Vx, so I'm going to multiply both sides by V, and I get that Vx, sorry, these are V's, not check marks, Vx is V times the cosine of theta. Okay, so hopefully that all makes sense. This V is your total speed. This is the sine of the angle. This is how much of your speed is headed upward. All right, we're going to do a goofy mnemonic, which you may use or not, and I'll give you 2 goofy mnemonics and then one another option. So, stop signs or stop signs are vertical. So that's how you know that your Vy, which is your vertical speed, is your total speed times the sine of the angle. Because stop signs are vertical, so you're going to use the sine function. Okay, this is a coastline, which if you delete some letters, you get cosine. Coastlines are horizontal. So if you want to know how much of your speed is horizontal, that's going to be V times the cosine of theta. And that's your coastline. If you don't like those goofy mnemonics, the other definition that's always going to work for you is if they give you this angle theta, so that's 15 degrees, 33 degrees, whatever, to use that angle definition is making contact with the blue leg. So whatever theta that you know, whatever leg it's making contact with is your cosine term. And then the opposite is going to be the sine. All right. Hopefully you like those. We're going to use those a lot, so you want those at your fingertips. Okay, so I'm going to show you the picture so you know what's going on. We're not going to do the whole problem because we don't know how to do that yet, but just to give you an idea, I like this problem. Maybe we'll do it in class. You are trying to win a carnival prize. So the speed with which you're throwing this little coin or something, a quarter, right? Because if you miss, then they get to keep your quarter. So you're throwing a quarter at an angle of 60 degrees. That angle is going to change with time as gravity pulls it down. But at that instant in time, it's 60 degrees. And you threw it with a speed of 6.4 meters per second. So in order to eventually do this problem, we're going to need to figure out how much of that speed is over. Technically, this is going to be called V naught because that speed is going to change, right? Gravity is going to pull it down. So V naught in the x direction is going to be 6.4 cosine of 60 because this is the coastline or because the angle that you know is making contact with this leg. Okay, make sure your calculator is in degrees. If you don't know how to do that, please ask in class. It's the mode button, which is right below the quit button. So at that instant, the quarter is heading over at 3.2 meters per second, 3.2 meters per second, period. Okay. And then the quarter is also instantaneously headed upwards. So if we want to know what the initial y velocity is, it's going to be 6.4, which is the hypotenuse, the green vector, times the sine of 60, which is 5.54 meters per second. Okay, you could check your work if you want. Pythagorean theorem, 5.54 squared plus 3.2 squared should give you 6.4 squared back again. And then the other thing you should check, I don't expect you to do that, but if you wanted to just make sure everything's consistent, what I do expect, to pay attention to is this angle 60 degrees is more than 45, and 45 degrees, you would get the same V naught x and V naught y. So since this is bigger than 45, you know that the triangle is shaped like this, and your V naught y should be bigger than your V naught x. So I do expect you to check your work that way. That should make sense. That, since it's a steeper angle, your up is more than your over. All right, that is the end of the play posit. That is your skill set for today. So katoa, a little bit of review, and hopefully it has a little bit more meaning now for you, and I will see you in class.